Hi, I'm going to show you how AI models think, visually explained. So large language models produce an output via two different processes. One is model training, the other is inference. Model training is done before in batches, and model inference is done in real time with prompts and context. Model training is done at a data center, which is a warehouse that has a bunch of computers that host RAM racks and GPUs. Models are trained by researchers. These are the people with the $1 million a year salary that you see working at Anthropic and OpenAI. And these data centers need a bunch of power to do computations and water to cool them. The act of training an LLM involves those researchers training a large neural network. This is what a very simple one would look like. A neural network which has an input node, hidden layer of nodes, and an output node. So you put in your token, which can be text or images. It tries to predict the output based on weights that pass through nodes and produces an output here. A large language model can come in multiple sizes. A small model can be 4 billion parameters. Medium-sized model can be 26 billion parameters. And large models can be 50 or 100 or 150 billion parameters. A 4 billion parameter model can usually run on local hardware and only needs about 2 gigabytes of memory or RAM to run. 26 billion parameter model can run on decent hardware locally at 20 to 30 gigabytes of memory needed, either that's RAM or VRAM. And then 50 to 100 billion parameter model, these are going to need 100 plus gigabytes of VRAM, top of the line stuff from NVIDIA. That's going to have to be run at a data center. So let's talk about model size and trade-off. So as your model size increases, so do your computational needs. Small models usually can be specialized and run locally. They can be open source, while large models typically are generalists and handle a multitude of tasks pretty well. Now we can move on to inference. So let's say you're on your phone, you put in a prompt, and then you also can add other contexts such as PDF documents, or you can what's called RAG to a database, or you can add context via tools, via a process called MCP, and you can connect to things like Salesforce or Slack, etc., to in real time give more information to that pre-trained large language model to more accurately produce outputs you want. So effectively, a model is trained once. Let's say that is GPT-5 or 5.2, or maybe it's Sonnet or Fable, and then plus your prompt and context that you add, it then can produce an output of tokens. One final point is, depending on what the model was trained on, can really affect how well it performs at certain tasks. So data that you might input to train a model, you could input things like novels. So you can input a book. If you want it to be a really good creative writing tool, you may want to put in Instagram images if you're Meta to be really good at creating images of mountains or landscapes. And if you are Google, you may put in billions of hours of YouTube to be able to make movies. All in all, there is the trained brain or model that is trained one time. And then there is the inference, which is like that brain thinking based on your prompt and context. And this happens every time. Maybe this happens 100 times. Every time that you call the model.